so. And we're going to open up a new job, and for that base it's going to be we'll go 160. The actual base diameter is 155, but I want a little bit of clearance room. 60 is already set at 20mm thick. Z0, top of the block, top of the work, and that can be left as it is, because we're going to be working all from the top of the material anyway. So I'm working in millimeters, and we'll OK that. Now this is that little glitch that I was speaking earlier about. I don't know what it is with the program, but I've always had it. There you go. Okay, so what we're going to do first is I'm going to get the circle tool, come to roughly the middle, and pull it out. Now over here in this dialog box, we can specify exactly what we want as a diameter. So it's 155, and we can zero it into the center of the work just by putting a 0 in the X coordinate and a 0 in the Y coordinate, and create. And there's the outer circumference of our base. So now what we need is another, so we need to carve out the central area like so. We only need a 50mm diameter area carved out there. Oop, not 500. 50mm, and again 0x 0y, and create. There it is. We need another circle now. Now this is for the, actually I'll come back to that. What we will do now is draw a box. I'm going to come here, and we're just going to draw it like so, because what we're going to do, we're going to cut a slot out there for the cable to come through. So the length doesn't really matter so long as we protrude inside the inner circle and protrude outside, so it gives a clear slot through for the cable to go to. That's going to be 10mm wide. Oh, sorry, high. And the length doesn't really matter. It's okay. We leave this as it is, because that's indicating from the central position, this line out here is 51.84mm from the central area. That doesn't really matter to us. But what does matter is the Y coordinates. We want it in the center. So we can just put 0 and create, and there it is. And it automatically centralizes. And we're going to get another box now, because we need an area to actually clamp the cable with a small bridge, little plastic bridge that goes over the cable. You screw down to clamp it there, so if it's not, the lamp is knocked over or cable is pulled in any way, you don't have live wires coming out, so it's makes it pretty safe. I'm going to make that 7mm wide. I know that the piece of plastic that I've got to go in there is 5mm, but I want a little bit of wiggle room. I'll make it 25mm long. And then again we'll 0 the Y, so we know it's everything's central and square and nice. And we will create. Now we need go back now to the circle tool, and we're going to come to about here. That's roughly there. And we're going to make a 10mm hole. Oh, the y-axis is already set at 0, so I know it's centralized. Now the cable's going to come along here and dive up through to go to the underside of the light fitting to take the feed in. And we're going to create, and that's done. So the underside and the basic shape from the underside is there, it's done, as in drawing wise. Now prior to actually cutting this out, I'm going to put another, if you notice, this indicates to me that it's automatically centralizing, so the program actually reads what you're doing as well, and it sort of gets used to the idea. Okay, now this we need to be precisely that's a nice snug fit for the tube. It does actually slip over on that nicely. X is 0, Y is 0, and we create. Now that is going to be machined on the other side of the material, because at the moment what I have a square block of 20mm, 160 by 160, and on the other side I have a 100 by 100 square block actually stuck to it, glued to it, ready to be machined. So this larger circle in the center here is going to be machined off the other side. So we'll come to that in a minute anyway. Okay, let's start machining. So come over here now to the tool paths, and our first machining is going to be the, just to give it a little bit of parameter, makes life a little easier. What I'll do is I'll just draw a box out here, and I find this the easiest way to do it, create, because what I want to do is I want to machine all this material away here and leave a lovely circle, but I want to give the tool, the program, a parameter to go out to, because sometimes you may leave a small amount on the edge of the material. So we'll select that, hold shift and select that, and now we'll do an area clearance. Now we want the cut to start at 0 and finish at 20mm in depth. Machine safe 25mm above the material, that's okay. I'm going to add a tool. Throughout this whole process we're going to use a 6mm end mill with 2 flutes. Now for this outside cut we can leave the step over at 1.8. That means for every pass around it'll step into the fresh material 1.8mm. Now the feed rate. This is automatically set for a smaller machine. Now the machine that I've got out there will actually cut at 80mm a second. This is millimeters per second. It's automatically set at 20, so we're going to say we want 60. Now bearing in mind I can actually alter that feed rate from 120% of that figure all the way down to 0 pretty well with the NC Studio program. So I have full control over the feed rate and even the spindle speeds. I can alter these on the fly. Now at that feed rate, 15,000 RPM, is not quick enough, so we're going to alter that to 18,000 RPM. For this particular job, I use an offset raster, and we are going to machine from the outside in. I'm going to use ramp moves. Now, the tool. So it's cut number 1. Just I abbreviate everything, but I put all the information in there just to remind myself, really. 6 millimeters, and it's a E mil. Calculate, and that's that. I'm going to close that dialog box. Now what we're going to do is carve out the centre part now. So it's an area clearance. Again, we're going to start off at 0. This time I'm going to go down 12 millimeters. We're going to use the same tool, 6 millimeter end mill. But this time we're going to change things a little. We're going to actually slow the feed up a bit, but I'm going to go 30 millimeters this time, and we'll leave that at 15,000. Same offset strategy. Inside out is fine. In other words, we'll start from the center of the material and we'll work our way out, and we're going to use ramp maneuvers. That means we're going to go down into the material like this instead of just straight down in. And this is cut 2. Cut 2. And I still remind myself, I always put what tool it is. Just in case I forget. And we calculate that. And it is done. So close that section. We got the first 2 machining strategies here. So we'll turn those out. And we'll choose this slot to slot material out. There again, it's all the same machining process. It's an area clearance. This time we're going to finish at, we're going to start at 0, top of the workpiece, and we're only going to go down 10 mil. Again, 6 millimeter end mill. We're going to leave this feed rate at 20. Leave everything as it is, because it's fine. It's only a very small area. And what happens if you speed the feed rate up in a small area, the machine sort of moves very quickly and it gets a bit jerky and it starts up a bit of a vibration, and it can leave chatter, machining chatter. So on a larger area, yes, you can get away with that fine. Smaller area, no. Okay, cut 3. It's again 6 millimeter. I just had some friends come in to see me. Yes, I know. Come around here. Oh, hello. Come around here then. I'm on there. So you know your spot. There you go. Morning. Okay, so that's done and we can close that. And get rid of that one. Now we can choose this one. Now this, as I've explained before, I think, that this is just a little slot we're going to put a bit of plastic in with the cable comes through to just grip the cable for a bit of safety. Area clearance. This time we're only going to go down 5 millimeter. Actually probably go down 6. And tool again is going to be a 6 millimeter, and we leave all the settings as they are, except for that one. Do that, and this is cut number 4. When you get used to doing this, you can actually do it quite quickly. Probably quicker than what I can. And something like this should only really take 5 minutes, I suppose, when you're really proficient at doing this sort of thing.